Imagine a piece of malicious code so fast, so aggressive, and so mathematically optimized that it infected its entire global target population in just 45 minutes. It did not target Windows, it did not target email attachments, nor did it wait for any human to click a link. Instead, it attacked the very security software meant to protect its enterprise network. This is the story of 2004's Witty Worm, a masterclass in hyper-viral propagation and sheer unadulterated malice. In order to understand the Witty Worm, we need to go back into its history. The Witty Worm was a computer worm that attacked firewall and other computer security softwares written by a particular company, namely the Internet Security Systems, which was then taken over by IBM, making it IBM Internet Security Systems. It was the first worm to take advantage of vulnerabilities in the very pieces of software designed to enhance network security. As we can see on the Wikipedia article, it first propagated on March 19, 2004. The name of the worm was given Witty because of the interesting and clever messages in the worm's payload. The shocking part of the propagation was within 45 minutes it infected more than 12,000 computers and was generating 90 gigabits of UDP traffic. In order to understand more about it, we can head over to this website, kaido.org. This article mainly comprised of the analysis done by Colin Shannon and David Moore. The analysis shows within 10 seconds the worm had spread to 110 hosts, which is not natural at all. This indicates that the worm's hit list comprised of vulnerable hosts which were already infected by other worms, namely CodeRed, Nimda, and SQL Slammer. In this graph, we can see that the number of hosts grew at the beginning, but then it began to fall. To find the reason of this, we need to delve into the source code of the payload. The first part of the malware comprises of network initialization. What it does is it loads WinSock and creates a socket that gets attached to this on the port 4000. The next part is seeding the random number generator. It resolves kernel32.dll and getTickCount. It calls getTickCount and stores the number 20,000 as the loop counter. The third part of the program is the UDP flood/network scan. In this part, we can see the malware uses the rand function to generate pseudo-random IP addresses for it to send the UDP packets. The next and the most devastating part of the malware is the disk wiper. Once the 20,000 network packets have been sent, the malware moves on to destroy the host machine's data. It targets the physical drives and calls create file asking for generic write access to the raw physical disk, bypassing the file system and allowing it to override the disk at the sector level. If it successfully opens the drive, it generates another random number and calls setFilePointer to jump on a random location on the physical disk. It specifies a length of 64 kilobytes and points the data buffer to the memory address. It overwrites 64 kilobytes of the hard drive with whatever is located at the memory address. Finally, at the very end, it hits the jump instruction, which causes it to loop infinitely. What it essentially does is send 20,000 packets to random IP addresses and then rewrite 64 kilobytes of data on the disk itself, corrupting the memory as it progresses through the loop and corrupting the device to such a point it becomes unusable. This repeated corruption of data causes the machine to eventually crash because it has override critical OS files or the master boot record. This is the reason why the malware's host gradually decreased over time. Slowly, systematically, infected firewalls and servers were eating themselves from the inside out. Within an hour, infected system began crashing as critical operating system files were overwritten by random junk. VT only infected around 12,000 to 15,000 machines globally. The scariest part, the timing. The vulnerability in the ISS software was published on March 18, 2004. The Witty Worm struck roughly 36 hours later. This wasn't a script kiddie playing around. The code contained distinct structural elements suggesting a highly skilled author who likely had a working exploit before the public patch was released. It was one of the earliest clear examples of a weaponized zero-day exploit deployed with maximum destructive intent. Witty fundamentally changed how security analysts viewed network worms. It proved that our security infrastructure could be weaponized against us. and that a devastating global outbreak could execute entirely within the span of a single lunch break. It remains a stark reminder that in the world of code, efficiency can be the most dangerous weapon of all.